Welcome to another Kuta worksheet tutorial for geometry. This time we're doing quadrilaterals in the plane. It should say coordinate plane, but it just says in the plane. So we're going to go ahead and jump right into this. I suggest watching some of my other videos because I'm going to be kind of going quick just so I can cover a lot of material. And as you can see, we're going to start with letter B. A quadrilateral can also be classified by characterizing its diagonals. I've already drawn this shape. I think I forgot a letter here. I forgot to label this R. But I already have the shape drawn with vertices as it describes here. And the hint it gives is by characterizing its diagonals. Okay, so what we're going to do here is I'm going to show a variety of methods to find some information about its diagonals. Now, what I'm guessing here is at once is it doesn't look like these are perpendicular diagonals, so we can probably exclude it from being a rhombus. Now, rhombus and squares have perpendicular diagonals, so this one I'm guessing is not perpendicular. So I'm guessing just by the shape of it, just because it's fairly obvious, I'm going to say that these might be congruent diagonals. So if I'm trying to find if two diagonals are congruent, I'm going to be using the distance formula. Okay, so distance formula is the square root of the difference in x's, x2 minus x1, minus x1 squared, plus the difference in y's. Okay, so I'm going to start using that, and I'm going to use the distance formula on the following points. I'm going to use it on R and I. Okay, so I'm going to show the distance of RI in just a moment. So RI, that segment, that diagonal, okay, we're trying to find that, is going to be equal to. Now, what I'm going to do here is I'm going to label this x1, y1, x2, y2. I'm going to show you another way to do it right in case you don't like the distance formula. I personally am not a huge fan, but sometimes it's useful. So my x2 is 0 minus my x, my x2 is negative 1. Apologies. My x2 is negative 1. My x1 is 0 squared plus my y2 is 5. Sorry, it's a little hard to see. 5. And my y1 is negative 2. Whoops. Minus negative 2. Yep, okay. And squared. So I'm just going to simplify from here. Parentheses first. So we get negative 1 squared plus positive 7 squared. So I get square root of 1 plus 49 equals the square root of 50. I don't need to simplify the square root of 50 because I'm just comparing the two diagonals. So I finished with RI, and now I need to compare it against TG. So let's use a different color for this. So TG now is the next one I'm going to do. So I need to find this length, TG. Now I'm going to use a different method. This time I'm going to use Pythagorean Theorem. How do I do that? Well, first thing I need to do is I need to create a right triangle. Pythagorean Theorem is all about comparing right triangles, so I'm going to do that right now. So I'm trying to create a right triangle between those two purple points. So there's one, and then let's create, let's make it red. Oops. I don't know why it does that sometimes. It's like the paint drips almost. Okay, this is a 90-degree angle, so I know it's a right triangle. So if I were to draw it real quick, it would look something like this, where the green is the diagonal, and also the green is the hypotenuse. As we know, a squared plus b squared equals c squared. Now you might be thinking, okay, what the heck are you doing? We just had the distance formula. Why are you doing Pythagorean Theorem? The distance formula is derived from Pythagorean Theorem. So if you have a coordinate plane and you can count easily, I think it's actually a lot easier than doing the distance formula. So here we have this red line. I'm just going to count over 1, 2, 3, 4, 5. And I know it's 5 units in length. So 5 units, 5 squared. Okay, see what I'm doing here? Now I'm going to count, I'm going to count the yellow line. So the height, 1, 2, 3, 4, 5. This is also 5 units. Okay, so we have, it's a 5 by 5, and I can just verify that, 5 by 5. Okay, so it's 5 by 5. So we have 5 squared, and then plus those two, and this can be equal to c squared. Okay, now I'm just going to simplify. So I know 25 plus 25 equals c squared. 50 equals c squared. And to get the c by itself, I need to square root both sides. And I get square root of 50. Okay, what did I get before? So I got tg equals the square root of 50. Guess what? They're the same. They're the same length. If they have congruent diagonals, then it classifies it as of a rectangle. Okay, rectangles have congruent diagonals. Isosceles trapezoids have congruent. This is definitely not a trapezoid. Okay, how do I know it's not a trapezoid though? You might ask. Well, you can find that out real quick by doing slope. So slope is rise over run. So what I'm going to do right here is I'm going to find the slope of opposite sides. So this side and this side I'm going to find the slope of. And let me do that real quick for you. So rise over run. So I'm going to go up from the left point, up 1, 2, 1, 2, 3, 4. So I went up 2 over 4 was my slope for that line. Okay, that was TG, TI. Then for RG, I went up 2 over 4. Actually, that's up 1 over 2. Sorry, my units are a little bit off. It's the same thing though. 1, 2, and then RG, slope was the same. Okay, so opposite sides are parallel there. We should probably verify the opposite sides are parallel here also, right here, with these green ones. So we have TR slope is equal to down, okay, I'm going to go from here, 1, 2, 3, 4, 5, 6. So I went down 6. Negative 6 over, that's my rise, over, how much do I go over? 1, 2, 3, over 3. So that's equal to negative 2 is my slope. And I just have to do the same thing here, and I go 1, 2, 3, 4, oops, sorry, 1, 2, 3, 4, 5, 6, over 1, 2, 3. So I get the same thing. That was slope of IG slope was equal to negative 2. Negative 6 over 3 reduces negative 2. So we see that we have parallel slopes. They have the same slope, which means they're parallel. And if it's a parallelogram with congruent diagonals, then that means it is a rectangle. Now, it's a possibility that it could be a square, but clearly it's not a square. If you wanted, you could use the distance formula on those sides to see that they are not congruent. So this is definitely a rectangle. Let's move on to the second part that I wanted to demonstrate. And that's more quadrilaterals in the plane. This time it gives us some information. It says classify quadrilateral bear, B-E-A-R. I just drew this just so we could get an idea of labeling some of these things so that we have, just better indication. So let's start with slope of BE equals 1/3. Okay, so this is BE is 1/3 and EA is negative 3. Slope of AR is 1/3. Okay, so this was slope equals M is like is abbreviation for slope, 1/3, and this was negative 3, and this one was negative 3. Okay, so as you can see, opposite sides of this, opposite sides are parallel because they have the same slope, and same deal here. So we know it's at least a parallelogram. Okay, what else do we know? Oh, we know that these two sides are perpendicular. Why? Because they have opposite reciprocal slopes. Okay, one is 1/3, the other is negative 3/1. It went from positive to negative, and then we flipped the top and the bottom, the reciprocal, to get opposite reciprocal slopes. Therefore, these are perpendicular. You can see that that's the case for all of these. So now we know it's at least a rectangle, okay? Now let's look at the lengths of the sides. We see the lengths of all the sides are square root of 10. So it's a rectangle with congruent sides. Therefore, BAR is a square. And if I could spell square, that'd be great. Square. Okay, bear. We got a Wizard of Oz themed here. Oh my. We can see that so I like to draw it out first just so I am aware of like what shape I'm looking for. O, H, M, Y. You got to go in order. OHMY. So you see OH has a slope of -1/3, HM -3. This one's a trick. It wants you to think that these are opposite reciprocals, but they're not because they're both negative. So these are not perpendicular, okay? So don't draw a 90-degree angle in there. So we know it's not a rectangle. We know it's not a square. So the slopes, though, are parallel to each other. These sides are parallel, and these sides are parallel because they have the same slope. Okay, so the length of OH is square root of 10. Okay, so we have, looks like opposite sides have the same measure, but not all sides are congruent. So it's not a rhombus, it's just a parallelogram. Okay, so that's how we know that. There's one more section I want to get to. Okay, this one has all congruent sides, so we know it's either a square or a rhombus. But notice how these are not perpendicular slopes, so there's no perpendicular angles. Okay, this is just real quick kind of noticing this. So it's definitely a rhombus because all the sides are congruent, but we don't have perpendicular angles, therefore all angles are not equal. So it is just a rhombus and not a square. Okay, I'm going to skip down to this section over here. This one just looks like a quadrilateral. Look at the slopes, all different slopes. I don't know if we even have parallel lines there. This is perpendicular, but that's the only 90-degree angle we have. So I think this is just a quadrilateral. Okay, no parallel lines, it's not even trapezoid. Okay, so we're going to do a couple of these and then we're going to call it quits for the day. So if this is true, diagonals bisect each other, then the quadrilateral is possibly a parallelogram. Okay, that's the first one. And if it's a parallelogram, that means it could be a rectangle, it could be a rhombus, or it could be a square. Okay, that's under the umbrella of parallelogram. Diagonals bisect each other. It doesn't include trapezoid and all that. How would you use coordinates to confirm this? Well, you would have to find the midpoint of diagonals. And just if you want to reference how to find the midpoint, you find the midpoint by doing x1 plus x2 over 2. That's your x-coordinate, and then y1 plus y2 divided by 2. So you're trying to find the midpoint between 2 points. That's how you do it. Diagonals are perpendicular. There's only 2 that it applies to. Actually 3. There's the rhombus, there's the square, and there's also the isosceles trapezoid. That's false. That's the kite. Sorry, I was thinking congruent diagonals. And that's the next one. So rhombus, square, and kite all have perpendicular diagonals. And then how would we confirm this? We would find diagonals slope. Diagonals slope. Slopes. Okay, and that's because they need to be opposite reciprocals. All right, diagonals are congruent. What color haven't I used? I'll use this dark green. That applies to the square. That applies to the rectangle. The square's got everything. And that applies to the isosceles trapezoid. And then for this one, you would use, let's use this dark blue. You would use the distance formula on the diagonals. Distance formula or Pythagorean theorem on the diagonals. Diagonals. Okay. So name all possible quadrilaterals that have the combinations of properties listed below. We'll do a couple and then we'll call it a day for this video. So both A and B are true. So diagonals bisect each other. Okay, so it's one of these 3 possibilities. And then diagonals are perpendicular. So it has to be an intersection between those 2. The only ones that have both those properties are rhombus and square. They belong to both categories, so that's how you determine it. So we have rhombus and square. Okay, diagonals bisect each other and they're perpendicular. Okay, both B and C are true. Okay, so let me, I want to be able to erase this. See if I can do this very carefully. Oh, looks like I got it. Nice. Okay, so both B and C. So now we look for both an intersection of B and C. So what applies to both B and C? I'm going to keep that for there. We see squares listed there. And it looks like that's it. So just congruent diagonals and they're perpendicular, that only applies to the square. A, B, C are all true. Okay, so that's only the square again. Okay. Now we're on A, B, C as false. Okay, so which one doesn't have those things? So we could put trapezoid, just a regular trapezoid. Diagonals do not bisect each other. Diagonals are not perpendicular. Or just like regular, I mean, there's a bunch of shapes you could put. We could put a circle for all we know. Oh, square, rectangle, rhombus, trapezoid. Okay, those are the only options it gives. Should have read the instructions, so that's just trapezoid for this one. Okay, A, B, C are true. B is false. So we're just looking for A and C. So it's not square because square also has B true. A and C. Okay, it looks like rectangle is going to be our answer there. Okay. How many more do I have? I'll just finish it. B, C are true. A is false. B, C is true. A is false. So diagonals are perpendicular. Diagonals are congruent. This is interesting. I don't know if it has. Diagonals are perpendicular, diagonals are congruent, but the diagonals do not bisect, so it's not a parallelogram. This one's got me stuck. Or just generic parallelogram or generic quadrilateral. Square, rectangle, kite. I'm going to be honest, I don't think it applies to any shape. B and C are true. Diagonals are perpendicular. But it cannot have diagonals bisect each other. Diagonals are congruent. I don't think that applies to any shape. I'm going to say not possible for this one. A, B, C are false. So that's going to be, again, either a trapezoid or a generic quadrilateral. So I'm just going to put trapezoid here. Okay, could apply to, I'm going to put, I'll put quad. A and B are true. Which one did I put this one for? A and B are true. C is false. Did I put that one right? Diagonals are congruent is false. Diagonals are perpendicular. Oh! Did I put this in the wrong one? Maybe I read this incorrectly. C is false. So it's not a square, rectangle. A and B are true. Oh, I'm looking at rhombus for this one. I'm sorry. I don't know why I put trapezoid. This has got to be a rhombus. Sorry about that. I don't know why I must have read that one wrong. Okay, B is true, A and C are false. So that looks like kite. And then A, B, C are all false. Didn't I already have that one? Am I reading this right? Both B and C are true, A is false. Not possible. A, B, and C are all false. So it could be, I think this one could be a trapezoid or a quad. A is true for the first one. Diagonals bisect each other. I don't think A is true, B and C are false. Diagonals bisect each other. Oh, that's parallelogram. Sorry. I don't know why I put trapezoid quad. I must have just been misreading this. I apologize. I'm not sure why I'm going through. So this one, parallelogram. That's the only generic parallelogram. This is trapezoid or a quad. So sorry about that. Hopefully that wasn't too confusing. I hope you guys got something out of this video. Hope you learned something. Hope you enjoyed the video. And then maybe I already said that, but have a good one. Hope to see you next time.